Okay, so in this video, I'm going to start the process of explaining to you why the numeral that's called dec looks the way that it does. So in my last video, I shared with you that it has this sort of a shape where it's like an X, but there's a little line going out there and out there on that side or on that particular part of the symbol. So I've been explaining in my past videos how I feel that somebody actually used this geometric pattern to create the numerals. And just to be clear, what we're doing is we're finding the points that define each of these circles. And just to talk a little bit more about this particular geometric pattern, because it doesn't seem to be a pattern that anybody's really familiar with. Most people are probably familiar with this inside part here. And so I want to just point out that this diagram has a lot to do with the value of pi, or exploring the geometry of pi. So we know that the formula for the area of a circle is pi r squared. So this circle is actually a series, or this diagram is a series of consecutive square root radius circles. So the first circle has a radius of the square root of 1, or 1. Second circle, square root of 2, square root of 3, square root of 4, square root of 5, and so on. So we can figure that out by using the Pythagorean theorem. A squared plus b squared, two sides of a right angle, equals c squared, which is the hypotenuse. So that length of 1 squared gives us 2. So this line is hypotenuse, square root of 2. So that circle there has the radius of square root of 2, and the area inside that circle is going to be 2 pi. We're squaring a square root, 2 pi. The third circle is going to encompass an area that's 3 pi and 4 pi. So if we subtract this first one area of pi from 2 pi, we discover that actually this ring, the area of that ring is the value of 1 pi. And that's actually the same for all of these rings. Each of these complete rings has the area of 1 value of pi. So this is actually a diagram that has lots to do with pi, which is a very famous, if not the most famous number in all of math, apparently. And yet this diagram seems to be catching everybody by surprise, and no one's really familiar with it. I'm actually asking this question right now. Why is this diagram, why is it missing from mainstream math curriculum? Why is it not in any textbooks? Doesn't have a name, doesn't have a presence within the canon of mathematical exploration, and yet it's completely to do with the value of pi. So I'm just going to actually leave it there, but in the next video we're going to get into why the numeral for dec looks the way that it does, because we're looking at the points that define the positioning of each of these circles.